Mujtaba, welcome to Clean Titans. Let's bypass the traditional introductory pleasantry and go straight to the first principles bottleneck. You co-authored an analytical piece for the World Economic Forum, noting that Pakistan's rapid, uncoordinated solar boom has sent the national centralized utility grid into an operational tailspin. You used the chilling phrase, the utility death spiral. Explain the mechanics of this phenomenon. When the marginal cost of a rooftop solar photon hits zero, how does it mathematically bankrupt a legacy state utility model?
Fantastic, Ali. Thanks for having me. It's great to be here with you. And I appreciate the fact that you read it and you absorbed some of the key messages there. And yes, that utility death spiral is the term I coined for what's happening here in Pakistan. And if I take you back to the fundamental reasons why this might be happening. Number one, we have always been in an energy crisis in Pakistan, right? So it's been planning, foresight, lack of transparency in how we have procured and sold energy in the country. If I can state some of the key issues, problems that you have with the power system and the utility, number one, only caters to 70% of the country, 30% remains off-grid. Parts of the country that are on-grid, historically they were run by a single utility called Water and Power Development Authority. That authority was disintegrated, was broken down into several component parts, including generation assets, transmission assets, and distribution assets. And several different distribution companies were formed by division. And what it did was basically, the idea was to do some market reforms and bring private players into the market. But fundamentally, the government never followed through end-to-end on that reform agenda. And as a result, good parts we had from a single utility where there was integrated planning, that was lost. Every system has its positives and negatives. So in the old system, at least we had integrated planning went away. And yet, we did not follow through on the complete reforms. And what you had is a disparate number of different utilities, state-owned companies that now don't see eyeball to eyeball. They don't talk to each other. And as a result, generation doesn't talk to transmission does not to distribution. And we've gone from, as a result, crises to crises. In the 2000, when there was a dictatorship of Mr. General Pervez, we went into an energy deficit situation. And as a result, come the 2010 onward decade, a large number of, especially under the regime of Mr. Nawaz Sharif, post to 2013, a record number of new IPPs were commissioned with China's help under CPEC. And of course, because there was no integrated plan, we ended up commissioning more than what we needed. And yet we did not upgrade the transmission distribution system to cope with all of that extra power that was coming through the system. And the way it was done, because the government was the sole buyer and the sole seller of the power, that monopoly system resulted in uncompetitive rates of which the power was procured, right? There was no auction mechanism, there was no price discovery. As a private business, when we procure something, we fundamentally ask for 3 quotations, minimum, and you go for the most competitive one. That process is not followed. You could be a developer and you go to the regulator, NEPRA, which hardly has any capability to assess tariffs, and you could submit a cost plus model, and NEPRA would, in most cases, accept your assumptions on those costs, which could be bloated in most cases. And we end up buying a lot of very expensive power. As a result, what happened? Today, we have 47 gigawatts commission of power assets or power plants connected to the grid under the IPP model. The peak demand this year probably was around 25 gigawatts during summer, and it tanks or goes down to around 8 to 9 gigawatts during winter. That's the peak demand, right? Our transmission system, as accepted by the State of Industry report that NEPRA publishes, can only carry about 21 gigawatts of that. So we never built the transmission distribution capacity. Even if we had demand up to that level, we could not carry it. Different parts of the country. In Pakistan is a big country, as you would know. There's north and south. There's load centers are up north in Punjab. There's the energy produced in south in Sindh or in KPK through Hydel, right? And all of that has to be carried to the demand center, supply in the center of the country. So unfortunately, not having that transmission capacity is also a huge bottleneck. As a result, under the cost plus model, you pay a capacity charge and energy charge. When you don't have the demand that you forecasted, your cost per unit goes up because your fixed cost remains the same. You have to pay that fixed premium to the developer over the next 10, 15 years under the IPP model. Unfortunately, whether you procure or you don't procure any power. from them. As a result, a large number of those IPPs remain idle, or were running at well below 50%, and yet we were paying the full cost of that power plant. As a result, the cost per unit went up. Mid 2010, our tariff was the highest in the region. And you know what that does to the economy. At high cost of energy, you can't produce it. Even if you produce, you can't sell it because your price is not competitive, right? You can't export if your producer is not competitive, right? So energy is the basic input to all industries. And as a result, industrial growth was hampered to this point, very high on the grid. Now, that's one problem, right? So the cost of energy is high. Number two, we don't have a very reliable grid. Deliberated, it's pretty old. There's a lot of investment into upgrading it. And as a result, there are frequent breakdowns. There are 5 different types of problems that industries face when using power off the grid, including voltage drops, frequency changes, rock off, name them. Frequent break. And industries have continuous processes. They cannot afford it. There's a huge cost of unreliable power that the industry has been facing. So power is expensive. The grid is unreliable. What do you do? Over the last 30 years, we had to work on self-reliance mechanism. And industry spent billions of dollars were spent on putting up power systems. Initially on gas, because we had a lot of abundant gas reserves in a province called Balochistan, and some in this large field in a place called Sui, supplied to all of the households and industries. So when gas was abundant, captive system was installed, mission, lots of generators were installed. So the spectre was that the industries would have access to a grid, but they will not use it because they can generate cheaper power and more reliable power using generators. So there's a boom in generator sales. Genbaka did pretty well. Wärtsilä has a large base, Man sold a lot of generators. But when this gas started running out, because there was no new investment into discovery of reserves, and unfortunately, because of the political situation and security situation, the large, big 5 oil and gas companies, which were doing majority of the exploration, went out of the country. So there was no investment going into discovering new sources. As a result, gas reserves kept depleting. Every year, 20% drop in indigenous, more imported. LNG import terminals were set up in the country. There are 2 in operation, and is now on. We are one of the largest buyers of LNG in this part of the world. Of course, you can see the variation in the LNG prices, right?
I heard that Pakistan was selling like tankers in January before the war.
Correct. They didn't need it because mix has been changing, and of course the demand has been plummeting on the grid, so you don't need to generate as much. And of course LNG is expensive, and we are trying to wean off the dependency on imported fuel, right? So it's challenge the industries and consumers are facing because changes in policy. And 4 years ago, the government started realizing that there's this large chunk of industrial demand, about 5 to 6 gigawatts, which is off grid, and these are well-paying customers with zero losses, right? They always pay their bill on time and so on, right? And their cost of service is lower because they have large connections. So they started thinking about, and I've been speaking to multiple governments in years on how to bring them back. And one of the ways is, of course, you give them cheaper power. So they started introducing incremental tariff. So if you have additional demand they want to bring to the grid, you were using captive previously, but now you want to come back to the grid, they offered a cheaper industrial tariff. On top of that, the government started squeezing them on gas. So they imposed the levy on gas usage for captive power. And of course, there was pressure from IMF to kill gas use in captive. They constantly were threatening industries over this period that they will cut off gas connection at some point. Industry will do something else. They imposed levy on another type of fuel, heavy fuel oil, which is also a major source for captive industrial plants, especially petrochemical plants, which can't afford any variation in their power. They were heavily consuming HFO, and they imposed levy on HFO. So now you had, over the last 12 to 14 months, grid became cheaper and gas and HFO-based power became more expensive. Now, all of those billions of dollars worth of assets became redundant, right, for the industries. And now they are having to invest large amounts into now coming back to the grid, make it reliable by investing in infrastructure indigenously, and secondly, large amounts of money on renewable energy. So while the industrial consumer is about 30% of the demand is residential. And of course, they were equally industries because means and the resources to be able to move to a captive system. Your residential customers are primarily connected to the grid. Their tariff is around 20-30% higher than industrial tariff because the cost of service is higher for them. And as a result, as the tariff increased over the last years, the tariff is at least tripled, shifting towards alternative sources. And we have seen what happened with renewable energy during this time. between 2010, 2020, decade of the Chinese production. Here they would double production. As a result, the rice law kicked in and the cost curves became cheaper. You had 25% year-on-year improvement in batteries, 30% year-on-year improvement in solar. As it got cheaper, the arbitrage became greater and greater, where in 2016, for the first time, we saw this positive arbitrage with grid prices a mile. Doing that gives you very, very good payback. And that resulted in a distributed solar power in the country, to the point that until Japan had imported 55 gigawatts of Chinese solar panels. Now imagine for a country which has a peak demand of 25 gigawatts, importing 55 gigawatts of panels. Of course, not all of that is consumed internally. There's some leakage in the system. But assuming large parts did get consumed here, you can imagine that during summer, peak time, 12 p.m., there's hardly any demand on the grid. Right, and that demand has been significantly displaced by this solar power, and watts of connections are net metered as well. So they are also not just their own demand, but they're putting also. So speak to the government. I tell them, listen, you need to change, because everybody knows what needs to be done and what's happening. I think it's just the pace at which they react is very slow. Right, and I'll give you one example. We have been talking about the single buyer, single seller problem, and we've been advocating for a wholesale market to emerge. Right, the government should not be the single seller, just like in the rest of the world. We should have a wholesale market, prices for power based on demand supply equation. Very simple, right? And everybody should form a view when commissioning projects on the demand supply equation. Years down the line, 10 years down the line, that's what normal business does. That wasn't happening previously because the government was taking all the guarantees, sovereign guarantees against it. That conversation has been ongoing for 7 to 8 years.
Wow.
Right? An agency was tasked with operations. Turkish consultants were hired to modulate on the Turkish model for 7 years. To this point, we haven't yet, wholesale market.
Moving ahead so fast that what is happening, keeps getting cheaper and better. And now batteries are following the same curve.
Exactly. This is the dilemma. Right? The real dilemma is the pace at which the regulators are moving. The world has completely changed. And this is why they find themselves in the situation where they are saying they are surprised or they're completely gobsmacked by the uptake of solar. But this was happening in broad daylight, right in front of them. The numbers were pretty clear. You could pull up the import data every month, and you could see how that demand is increasing. So they completely missed it in broad daylight. This was happening. So anyway, coming back to the utility debt spiral. Now, is this reversible? Ali, the fundamental question is this reversible? And the answer is, it might already be too late for the grid. And the reason is, when you have such a large amount of demand that goes off grid in a scenario where tariff is already expensive and the customers want to move away from it anyway, when more demand affects, more expensive it becomes, right? So that's the utility debt spiral. And it's not just that. And it causes huge management and reliability issues. So I can tell you the largest DISCO in Pakistan, LESCO, or electric supply company, has 4 million connections, constantly send out Mayday calls. And that's when their demand drops below half a gigawatts. This is a grid that is supposed to carry like 3 gigawatt. And they say, what do we switch on? How do we maintain integrity of the grid? It's such a low demand, right? So here's a huge problem for the grid to stay active and alive in this scenario. Now, that's where we are now, right? Huge amounts of demand every year continues to affect. I mean, we're maintaining a very high demand for solar, between 15 to 20 gigawatts every year, still being imported at a very high, rate. This year and last year, batteries have become the new game. And now everybody has probably installed solar up to their upper limit, which is their demand, off-peak demand, right, during the day. And then displace as much as they could. And a lot of industries and consumers are wasting some power. Right? Some are exporting, but you can only export from a system up to 1 megawatt. Bigger systems, which are the industrial systems, they cannot export to the grid. There's no policy for 1 megawatt. So what do they do? Two things. One, they waste curtail at that level, or they store it in a battery and run it during the night. And of course, peak tariff is more expensive. There's a 9-10 rupee arbitrage between the peak and off-peak tariff. So again, in broad daylight been happening, and the battery demand has been doubling every year. And now it's reached a stage where it's forming a hockey stick. And we've been saying to the regulator for the last 5 years, look, battery is just 5 years behind, guys. Get ready. Whatever is happening in solar will happen in bigger volumes with batteries. And that's exactly what's happening. The next phase is very deadly.
Sodium batteries are coming, which will be like 10% lithium.
I don't think that's
lasts longer.
Exactly. I think that they're going to be cheaper, more abundant, and I think you can even manufacture locally, right? So nothing's going to help the grid. in this scenario, right? So,
So,
and the law says you scale it and the cost comes down even faster.
yeah. And I think the future experts say that the future of grids is microgrids, like internet of electricity, not a big, massive central grid. That's
Correct. This has been our hypothesis as well since the day we started. The company was started about 12, 13 years ago. And we realized at that point, our past life, and we were, those experience curves. And we could see that the world is heading towards distributed, decarbonized, and digitized energy system. And literally, that's what we've been trying. That's the future we've tried to bring to a developing country scenario. And in terms of all the technologies that we've built and the IP we have developed, that more economical and sustainable.
Further into the systemic friction. If the industrial base leaves the grid because localized behind the meter generation is cheaper, the grid is forced to increase tariffs on the remaining low income residential customers who pay down its fixed debt and fixed costs. This accelerates the next tier of solar defection. Regulators typically respond with protective tariffs, net bans, or solar penalties. If you are sitting across from a minister of energy or a utility fund manager who views decentralized solar as an existential threat to the grid stability, how does a state utility survive when it no longer controls the point of generation or storage?
I think that's a great question. And I think this is a $1 billion question, right? In terms of how would this legacy system survive? And why it does not need to survive. Not everything can be a winner. When there's huge disruption happening, there are going to be winners and losers, right? So there's bound to be losers. And this is what typically a market decides who the losers are, the ones who are not competitive, the ones who can't keep up with the pace of change and technology will lose. And the pace of adoption on the state side or the grid side is very, very slow. And what happens to dinosaurs about 60 million years ago, Ali? It's no secret, right? So look,
it's adaptive to the environment, goes
correct.
away. Even today.
Correct. I think they're going to be winners and losers. Number one, I think the first fundamental acceptance has to be that not everybody can survive. Not everybody is going to survive this massive rate of change of adoption. The second question is, do we need the grid? Well, I think you do need the grid, right? And the grid is more efficient because, you have cloud, right? So they have this term for periods when you don't have any solar anywhere, right? And based on that, they say, you can't energy because they're bound to be times 12, 13 during their season that you're bound to get no power. But at the same time, you will have one part of Europe that will still be generating solar, will still be generating wind. Right, so to balance these things out, you do need the grid to carry nuclear, idle, right? To do and covering connections you have between different countries, the more stable your system is. Just the Iberian collapse last year with Portugal. I think one of the lessons was if they had more interconnections and more balancing between other countries, then they could have survived this. Right. So yes, you do need the grid in some shape or form. Not at the distributed level. Maybe you don't need all those 11 kV lines crisscrossing through cities. But yes, large transmission will be required in some shape or form. I think fundamentally, the utility networks, they should not be in the business of buying, selling power. And setting should be left to the market based on demand supply. That's very clear. In that scenario, there will be some sources that will lose out, and they'll have to go out of business. They'll have to shut down their power plants. Fundamentally, we have to decide whether we continue to carry the legacy inefficiencies and costs of bad decisions and let the industry and consumers suffer and result in more deindustrialization as a result in the country? Or are we able to draw a clear future, embrace what's happening, embrace these technologies and adapt them at a faster pace and change our policy accordingly, right? Encourage more of it. So whether we want to save a legacy dying system or we want to encourage more industrialization. And I think if you think logically about this, you'll realize we need to make more things. We need to increase production. We need to create jobs. We need to export more as a country. In order to do all of that, we will need to cut our losses and embrace the more economical, sustainable, reliable sources of energy. And I think at some point there has to be a write-off. Somebody has to take that write-off. Be it, the government, some settlement has to be reached so we can move into the future, from into the future. That requires political capital, that requires hard decisions to be made, right? And I think second thing, as I said, you can clear all of that, but still, if you don't move fast, the change is going to continue to accelerate from this point on. We can see it clearly, right? In terms of technology, competition, AI, and this introduction of AI and intelligent move much, much faster.
You get ranges and ACs and fridges that have their own batteries and plug and play solars, which is happening big time in Germany. And you can just plug in a battery and take some demand off or peak share.
I've always believed that batteries have been behind, use cheap, that you see shopkeepers using solar panels for I saw, and then same power is being used to run deep freezers. So people are using them as mirrors. And
I saw this guy with a donkey cart with like 6 panels on it, and he would from one tube well in a rural area in Pakistan and create a pool of water, then disconnect, go to the next tube well, and diesel generators.
Entrepreneur. What an amazing and enterprising person that must be. So amazing.
Danny Kennedy, he's a solar pioneer. And he said, that's 21st century mobile power for you.
Absolutely. And finding a solution for, indigenous.
Let's take it back. And before you're over 100 megawatt of industrial battery fleets and navigating complex energy ecosystems across developing markets, you were climbing the elite ladder of the FTSE 100. You were a core member of the BT Fast Track leadership program inside the top 1% of the workforce, managing a massive £2.5 billion flagship next generation access program. You had the corporate apparatus of a global telecom giant behind you. What shift internal of a person to walk away from that highly cushioned, predictable environment to take over the helm of a clean tech enterprise operating in a highly volatile emerging macro climate of that you are in now? What did you see about the future of global infrastructure that made the FTSE 100 corporate environment feel too small a stage?
10 years. And, I've been an entrepreneur since an early age. So got the bug, ran a software company, went to London, studied, and fast track leadership. That means that I was put across the whole organization, given diversity of experiences across global multinational 160 countries. Amazing experience, learned a bunch of things. But you take the man out of the country, not the country out of the man. And some of the experiences I had as a child growing up in a developing country stayed with me. And then there was always make an impact, make a difference, come by. The opportunity was served, and the largest industrial group in Pakistan reached out to me. It was accidental. I was sipping a cup of coffee in my office. They wanted me to visit. They wanted to, bring it. I thought that this was a perfect opportunity to take everything I learned in the Western environment, working for large multinational as an art, and deploy those tools for the good and make an impact. So I came back, it's fairly young, strategy for the largest industrial conglomerate. That's the first time I got introduced to energy. And I realized that, in Maslow's hierarchy, bottom of the Maslow hierarchy, right? Because you're still providing the basic stuff for the population. It's all about food. It's all about energy, education, health, right? So you're catering to all of those things. So as soon as I moved back, gone from crisis to crisis. A lot of people I knew who stayed back in Pakistan were now working in the energy sector. This is big. Was going. This is where the big opportunity was, because we were in the middle of a crisis where we had a deficit and large amounts of power was being put up. And this is where I caught the bug. When I looked at the state of the energy system and the challenge in front of, all of the need for energy transition, pace at which this transition has to be done. I read up. The world has made many transitions, coal to oil and gas. Now it's having to transition from, fossil fuel, hundreds of years. This one has to happen in 50 years, which is incredibly unprecedented. So that's where I got and I realized that the scale of this challenge is totally unprecedented. And that in itself presents opportunities to us as a developing nation, because everybody's starting at the same place. I saw opportunity to, get a difference, bring some of the latest in tech here, and also to develop some indigenous IP, intellectual property, that could make a difference in a developing country scenario. And that's what we've been doing for the last 10 years. It's been incredibly rewarding. And, that's the thing. And this is my advice to youngsters who are probably 20 years behind where I am. We should always think about what is that big world problem that you want to spend your life solving. Because to do anything remarkable, to achieve anything big, to make an impact, you need to spend time, and make the solution, understand it intricately, go into the depth, and then chart your own regional path solving that problem, and have found that problem with this energy transition, that I spend. That's what drives me forward. And I've never looked back, honestly, since I started running this company. It has become an incredible passion through the thick and thin, through all the challenges we've faced, through the transitions we've made internally. It's what you find meaning in. And that will give you the longevity or the staying power to be able to sustain all the ups and downs for different shades, probably they don't really believe in what you're doing. So that's where I'm in, and realize that I found that thing I want to work on, that problem I want to solve, and one thing led to another. Here I am running a company that has now delivered over 800 megawatts of renewable integration for industries. When I compare that to what others have done in other parts of the world, lots of done grid-based, IPP-based. Very few companies have had the experience of integrating so much renewable energy with captive microgrids. And I'm talking about all the different sources now: wind, solar, batteries, and then building the intelligence on top, the software, the AI platform, the leading AI platform in this space that is running. Has been an incredibly challenging but rewarding journey.
Let's dive into the physics of the hardware. Your team successfully deployed a massive, almost 24 megawatt solar array integrated with a 20 megawatt REFLEX BESS unit for Novatex Limited, creating the largest renewable energy microgrid in the country's petrochemical sector. Manufacturers cannot tolerate voltage sags. A 50 millisecond frequency deviation can ruin an entire production cycle. Historically, developers kept heavy, dirty diesel generators spinning at idle to provide rotating mass inertia. Your system achieves the entirety of this via software, running on a battery using a Virtual Synchronous Generator, or VSG. Walk us through the mathematics of virtual inertia. How does an inverter mimic the physical kinetic momentum of a 50-ton steel spinning turbine?
That's an amazing question. First thing I want to just clarify is that I am not an electrical engineer. Software programming started, and then business degree, one of the best technical teams in the world, and test out new concepts. When we brought industrial batteries to Pakistan for the first time, we were trying to solve an indigenous problem, which was this, variation and chaos in industrial power systems. We were working with a polyester yarn manufacturer in the south country, the largest one. And I saw in a given month, they had 11 breakdowns. Each breakdown costed them millions. Huge economic cost of, these technologies. And we used the first industrial scale BESS, at the risk were around 300 milliseconds. Now the PCS, which is the converter and the battery, and if you just look at the response time, that's quite instantaneous. PCS can respond within 20 milliseconds. But if you then take account of the whole system throughput, which includes the controllers, then the throughput was about 300 milliseconds. But as you put it, operate at 50 milliseconds is pretty common. And in order now invent something even more innovative. So this Novatex project you're talking about, it's not yet commissioned, by the way. We have done other projects like this, but it's underway right now. There's been a big study that's been done to address situations like this. Last year, we came up with a concept which in the West you would understand as an AI UPS. You might have seen this piece of news that a large data center operator in the West has now ordered 5 gigawatts, 5 AI UPS. So that AI UPS is something we invented last year in our environment. Basically, it's a double conversion system on top of a BESS, which provides you all the functionality for UPS, which comes through double conversion from AC to DC, DC to AC. And then underneath, you've got a BESS sitting there to provide 2 hours of backup in case of a breakdown. We invented that last year, commissioned our first, system. Of course, no lag. It's always on. So you can enjoy 5 different types of problems. Voltage sag is one of them, but then you have, rock off, different issues that you face. This system is always on, has predictability built into SPARK Energy Management System. Because we have now commissioned hundreds and hundreds of megawatts of this, we are receiving grid data from all of those sites. And in fact, we can identify patterns in grid breakdown. And based on that, we have that they provide reliability to industry. And this is the essence of what the Nova system is going to be all about. It's going to be 100% guaranteed reliable connection with 0 voltage sags, no interruptions, no rock-offs, no harmonics. So the Spectral plant, very largest spec manufacturer in the country, very well-reputed company, can operate their plant with a peace of mind that they haven't had in the past. So that's what it is. Absolutely groundbreaking, new concept in this part of the world. We have commissioned a few plants already, so we are very confident about the technology. Very high availability, 99.9% availability, large amounts of redundancy built into the system, zero lag, zero. So with that level of precision in the quality of power that we deliver to customers.
Excellent. That's remarkable. Very innovative. Let's drill down into the hardware controller loop. Standard grid following inverters read the grid's voltage, phase, angle, and inject current to match it. But in a 100% islanded microgrid, when a heavy industrial motor kicks on, the grid forming controller must instantly dictate the voltage wave. Your documentation highlights that Reon engineers its own indigenous local controller to handle this synchronization to record time. What were the computational latency limits you hit? Did you hit thermal or magnetic saturation thresholds when programming the power electronics to match the states of wind, solar, and other variations?
So that's way too technical for me. Look,
you can give an overview.
I can give an overview. So I think I can only cover the narration of the story, right? But of course, it's on a day basis been addressing those challenges and all of those challenges you spoke about. And yes, we have on microgrid architecture, we have on MGC, control logic on top, local controllers. It's been an evolution for the last 6 years. We have a silent mode or PQ mode to then having to build systems where the batteries were forming the grid under Virtual Synchronous Generator mode, VSG mode, and of course that took a lot of experimentation, a lot of skill to be able to set frequency, voltage, maintain it, with all and different types of equipment kicking in at different times. What we have, through the evolution of all of what we deliver and achieve, is a system that's many times reliable than what a grid-based system would be. Right? So in a typical system, in a scenario, you have the grid is very reliable. Sometimes the grid just goes away. If it doesn't go away, if the grid is too wobbly, you have to kick it out because otherwise it causes stripping in the system. Right. So what we've seen is when you have your PCS mode, you follow the frequency of the grid because the grid is basically setting the frequency, and you have a lot of variation. You still have a lot of variation, fluctuation between voltage as your grid is kicked out. But despite all of the variations in the industrial demand, you have a much more stable power curve. And it's on dashboards and you are able to operate in much narrower bands when it comes to voltage and frequency. This is resulting in a much more reliable system. You don't have a lot of tripping, even at a scale. Also, it causes, which may not be expensive and failing long lead, and you can't have an inventory for everything, right? So that results in a lot of downtime, lost production. So in essence, you are saving them from a series of different problems that they might face down the line. As I said, it's been an evolution. We delivered one. It's been a series of innovations we have had. In filed our first few patents in a Western market in London. We have filed a couple of patents. A couple of management, the way to battery management, the way the controllers work, and so it's unique and we've done it. We haven't actually copied anyone. Today, in the VSC mode, we can deliver much more reliable and bankable power would have in a situation.
Financial Times featured the Lucky Summit project, a massive 20 to 22 megawatt hour REFLEX platform. You stated that customer interest has literally gone through the roof because you are delivering a sub 1 year payback on an industrial BESS deployment. Anyone in infrastructure private equity, a sub 1 year payback on a heavy battery hardware sounds almost impossible without massive artificial subsidies. Break down the unit economics. Where is that value coming from? Are you capturing it through the absolute displacement of high-cost industrial diesel fuel, power factor connections, or the mitigation grid brownout losses? Give us the exact EBITDA impact.
Okay, so Ali, one thing you remember in batteries and BESS world, there's a concept called benefit stacking. What batteries provide industrial power grids, provide many power, is flexibility. Incredible amount of flexibility, high risk that could be seconds to any contingency, right? So what you have to remember is not all of that. There's a huge variety of applications that are available behind front of the meter, pretty standard in terms of what it does for the grid. But behind the meter, there's a variety of different applications. The project you spoke about, Lucky Cement, large cement decided to double up on renewable implementation, cost of energy, and to bring down the input costs, so they export large amounts of product. So and large amounts of solar at high point, they were curtailing a lot of that power. So they needed, number one, to store some of them, run it in the evening, so peak shaving. Number two, they won't need to provide for renewable contingency. So the thing with renewable energy is that, of course, it's intermittent, and there could be huge drops in power. Wind could drop by around 50%, solar by same 50% of their electricity. So in those capacity to be able to respond, and this was a captive system. So the battery's primary role was contingency management in terms of fluctuation in renewable availability, and number two was to store that excess power during peak and to run it in the evening. That fundamentally has changed the economics for that cement company, and they've been able to sell more. Fundamentally, what it also does is that it provides stability to the grid, because the grid in that part of the country, this company moved power to the grid, and when it did that, the grid reliability issues popped up, and the battery has been providing reliability services, voltage stability, through reactive power without loss of primary energy. So it's been helping maintaining healthy power factor. Of course, preventing what you call as an MDI, which is the peak charge, right? By limiting the grid at a certain level, we've been able to save them some money from, by limiting a series of different benefits being delivered, to the benefit stacking. Now, when you load all of those things up, yes, it has very attractive paybacks. Even in this case, there are many of the sub 1 year payback. I explained to you where we deploy these AI UPS or the grid conditioning BESS systems for petrochemical plants. These petrochemical plants are running captive systems with very high cost of fuel. When we're able to move them to the grid, the cost arbitrage between the grid today and the captive system is such that they get under 1 year payback on those systems, right? So quite literally, spectrum of different kinds of applications. The latest one is, of course, pure peak shaving. The peak tariff in this part of the world is between 6 and 10 p.m. or 7 or 11 p.m. And that's when the industrial tariff is the highest, and large amounts of deployments are happening to just displace that and shift solar, generate that the batteries for 4 hours. That is a typical application that is a 3 year payback in this part of the world, right? So there are also different applications for batteries. It comes, battery important thing is, of course, the intelligence and the software that then delivers those services. And again, that
Pivot to intelligent bits. At the Mobile World Congress in Barcelona, your global telecom team presented the SPARK AI ML powered energy management and predictive maintenance platform. The telecom sector and the mobile network operators are notorious for what tech founders call Pilot-Purgatory, where enterprise companies run endless test loops but never commit to commercial deployment. You stepped straight past the testing phase and deployed SPARK at scale, delivering month one EBITDA growth for global operators. How do you structure an artificial intelligence model to deliver instant financial returns on day one without requiring a long features of the telecom node are you optimizing instantly?
That's I think that's right. Yeah, the fatigue where test endlessly your product and then may or may not adopt it moving forward. Can't remember exactly the term used, but I think it's a real phenomenon out there. Our journey in telecom, I think it dates back to my time in BT. And when I was in British Telecom, we had a demand. BT was one of the largest consumers of power on the telecom tends to be the same power. And the demand for energy will keep increasing as you move from 3G to 4G, 4G to 5G. Because what's happening with 4G to 5G that you have two phenomena. Number one, in each individual site will now need more power. You've gone from 2.5 kilowatt on average to 6.5 kilowatt. And then there's this densification phenomenon, right? You need more sites, more access points, 5 to 10 times more access points are required in 5G. So demand for energy is ever increasing in the telecom system. Now, if you look at the structure of the telecom system, 80% of the power demand resides network, the BTS sites, the telecom towers, LAN equipment, and they tend to be quite homogeneous, right? If you look at the nature of the telecom towers, you have like 4 or 5. Nokia, Huawei, ZTE providing all that. It tends to be fairly, predictable grid sites. Another additional challenge that you face in a developing country is because, you have, that means 30% automatically off grid. Another 20-30%, the grid is not reliable, right? So you only have power for 4 or 5 hours during the day. That means it's pretty much off grid. So you need large amounts of, every site need to maintain high availability for these sites. Where there's diesel, there will be pilferage, there's going to be high cost of, transporting. On top of that, the grid, right? So there's huge amounts of leakage and inefficiencies in the system. In a country like Pakistan, you have 50,000 telecom towers spread across the length and breadth of the country. They could be up in the high mountains or, along the coast, to maintain a high availability for these sites and to manage the cost. So early on, we started experimenting with the telecom, solar power, and solar became cheaper for a multinational operator. And as soon as we stepped into the telecom operators are able to make sense of what's happening without use of technology. And that's when in 2016, 17, we started getting into the sensors, the aggregation of data on site, how that's going to happen. We got into gateways. For the first time, we experimented with putting smart gateways. These are devices that aggregate data on a site and then push it into the cloud. We could use GPUs to be able to push computation on the edge or inference on the edge on these sites. And as soon as we digitized these sites, we had these 1,500 to 2,000 data points at high frequency and high polling now aggregating into our, and we have something with the data. Initially, we just started doing some smart analytics, backward-looking analysis of what's going wrong, where there's a lot of improved performance. In 2018, we came across G at that point, 2017, in fact. G was being run by Jeff Immelt. Jeff Immelt and Predicts platform as a strategy, digitization of industrial assets, building data twins. We learned our first lessons in unsupervised learning and digital twins from G. And initially, we started developing our platform on Predicts. And the basic concept was build a digital twin using digital boundary detection, unsupervised learning, and that starts the model. And then over time, you become better and better at identifying anomalies and being able to identify root causes. GE stopped doing that after Jeff Immelt was fired in June of 2017, I think. I was supposed to meet him in July of 2017. We were about a global partnership. But we picked up that concept. And to this date, that DT, digital twin model, has been the fundamental building block of how we're building the platform. We started building twin towers back in 2020. And once we've been training the models for the last years to the point where for the first time when we deployed our AI-based capability called Insights with a large network here, accuracy of our algorithms in terms of identifying root causes of why something is wrong was 98%. Right? So all of that, you connect the of systems, demand, our understanding of the microgrids, that high accuracy, high precision data, and push into the cloud, identifying patterns of why you might be underperforming on solar, why you might be burning more diesel, maybe because the logic is wrong, or maybe there's some pilferage going on, why there are faulty. All of that is now a very high accuracy predictive model. That high accuracy predictive model allows us to do something called right first time, getting things right first time. And this is a point engineering outage somewhere. Engineering there realizes there are 5 other things wrong with the site before you can fix it, there's another month that has passed before the engineer can return and fix that problem. If you know exactly what's wrong, and you can find inventory required, you can create an intelligent ticket in a workforce management system, which tells the engineer, Mr. Engineer, go to this, walk into the warehouse, take a battery module because the battery is faulty, and make sure you carry tools XYZ so you get the problem right first time. That has huge implications for the future of how the networks will be managed. Number one, you have high availability, you have quicker resolution of problems, lower cost of energy, because in many cases it's really the power equipment that's faulty that needs to be repaired. Number two, the cost to serve. We could cost to accuracy predictive models for the networks. And that's basically what we're deploying today. That capability we've been deploying for networks in Pakistan, but we're deploying across Africa. We're picking up as well. And I think this is the future of intelligent systems. As you see that these frontier models graduate into the application layer, as they face more and more competition with the Chinese open source models, they're becoming more and more powerful. You'll see less and less value in the application layer, right? And what matters now is the outcome being delivered. And Reon's platform is in delivering those outcomes. So you asked me that question, how do you do it on day one? We do it on day one through a highly sophisticated advanced system that we've been training for the last 4 years. That can majority of we deploy the platform, it identifies those opportunities across the network and with high level of accuracy because it does it for other networks. We generate a ticket, that ticket is complete, and that allows us to get things right first time, resulting in network. And to we say to them, Mr. Customer, don't pay us anything up front. Pay us, a part of the under a gain share mechanism. And I'm proud to say that we are one of the pioneers. We are the pioneers of this in telecom and systems, pioneer of gain share contracts, and that's what we're delivering.
That was my question. That you see highlighted that your monetization architecture for SPARK is completely outcome-based and zero CAPEX. You are telling multi-billion-dollar infrastructure funds, we take zero upfront payment, we only win when you save. While this lowers the barrier to entry, it places an enormous balance sheet risk on Reon. If the asset operator has poor operational field forces, your software can recommend an action, but if the truck doesn't roll, the saving isn't realized. How do you mitigate the execution risk of your client's workforce? How does SPARK integrate with autonomous field force management to ensure software insights transfer into the physical savings on the ground?
I leave delving much into the secret sauce level. You hit it right. Commercial that has to be. And if you don't control the workforce, then you have a problem. And we are fundamentally solving that through hybrid, where we are forming partnership with what you call as managed service providers, MSPs on ground. And this is where we're driving where gains from with typically they have third-party providers who are active. It results in a lot of variance by turning its head, by moving it towards a predictive model. We believe that we can increase the longevity of these and also improve outcomes, improve availability, and reduce costs. We've had to take off products. We have an EMS that talks to our workforce management tool that manages the tickets and makes it outcome with all the stakeholders in the system. So it's delivered through an integrated suite of applications that are all indigenously developed by us. And secondly, through better controls and better incentivization mechanism with partners.
Let's look out at the next century of development. Reon has recently executed a deep strategic partnership with Virtual Energy, a subsidiary of the Invesco Group, to deploy intelligent renewable microgrids across Madagascar and expanding outward into the wider African industrial nodes. When you look at regions that completely lack legacy centralized transmission lines, you aren't just retrofitting an old system, you're executing a complete technological leapfrog, much like the mobile network bypassed landlines. As you stack these microgrids across emerging economies, How do you see them evolving? Does a Reon microgrid campus eventually transition from pure energy distribution into an edge computing hub, water purification matrix, or a localized manufacturing center, or a edge data center? What is the 100-year vision for these distributed source civilization nodes?
Ali, to be perfectly honest, look, I don't have a 100-year vision. I don't have a crystal ball I can look through and predict, and that those could be the famous last words. Right? A lot of people have tried to do that, and it fails. Some are pretty good at it, like Elon Musk. Maybe these people can drive the film. I think what we do is we'll, on a first look at it, and then where's the technology? What are the building today to solve those problems? And luckily, when you enter these frontier markets, there's hardly any infrastructure. Why has a country like Pakistan, why is Nigeria, for example, the leading adopter of distributed renewable energy? So why not UK? Why is it not US, right? In fact, as a percentage of overall demand, we have done more than developed countries in our part of the world. Same thing happened as you put it, like fixed line versus right coverage of fixed line, and also leapfrog to mobile adoption. And I think that's the flip side. One side of the coin is we haven't had energy deficit economies, but we now have the liberty of not carrying legacy systems and leapfrogging to what's available to us today. What we'll be doing going forward, I've always thought about this Nintendo model, right? So once you have energy, of course, that gives an opportunity. You've seen where you build a new microgrid, and for the first time, people have reliable power. And you'll see a lot of shops, small entrepreneurs now flocking to that opportunity. Somebody will set up an ice machine in a warm climate in Africa. Somebody set up an ice machine to sell ice, commercial scale. Other people set up storage. There'll be new shops, internet cafes spring up. So, there'll be this mushroom. So I fundamentally think when you get into a territory and you build a new microgrid, and for the first time providing energy, sometimes you have to act like Nintendo. You have to generate some of the games. You have to write the first few games and show people the way in terms of what can be done with this newfound source of energy. And I think that drives the economy. But fundamentally, we believe in getting better at what we do, not getting into the shoes of our customers. Our customers produce a variety of different things. They use that energy as input and produce some beautiful products. And I think that will be the case for us going forward. What we are building towards is fundamentally in the age of AI, intelligent, autonomous, incredibly efficient how they use different sources of power, incredibly efficient at balancing those grids, and will make up for much more efficient power systems at a much lower cost. So that's the future we're trying to deliver in these parts of the world. Luckily, if you follow that future to these parts of the world, because there's no legacy there.
Mujtaba, at Clean Titans, we believe that a truly profound conversation can reorient the trajectory of a person's life. You have transitioned from high-tech corporate management in London to building the literal foundation of the clean energy transition in some of the most challenging operational environments on the planet. When you look at the next generation of engineers, computer scientists, and young founders who are currently sitting in a safe tech job, writing optimization algorithms for advertising clicks or financial trading apps, what is your direct challenge to them? Why should they leave the comfort of their current work to the messy domain infrastructure optimization?
That's a great question. This goes meaning about earlier in the interview, and this fundamental question that I've asked myself, and then that I advise youngsters ask themselves: you spend your life solving, and that should be the first thing any budding professional coming out of the aspiring to make a society that big world problem you want to solve, and there are tons of problems to solve out there. Once you find that problem, fundamentally, it could be disease, it could be access to education, it could be access to clean energy, it could be peace. I think that for a professional life, for a small large, while that might appeal to a lot of people, what has always mattered to me is what difference am I personally making to the products work in the field, and when I see the impact it makes on the industries it serves, and the difference it makes with the economics and creating jobs, fundamentally changing the economic fundamentals in it, because we are a space. We need to solve for all these problems, solve for the inefficiencies. We need to industrialize, generate jobs for the future, continues to be that fundamental building block or input into producing anything. In the age of look at the most important commodities, two commodities going forward. One is compute, clearly, much in demand, video company in the world. But then what drives compute is energy. And I think learning how to be most efficient is going to be incredibly important, even more important than it was in the past. And more so because now it seems to be not just transitioning towards clean energy, but also transitioning to electrified economy. Electrification is happening. So fundamentally, the future of power system of the pitch to youngsters is a fascinating area, fascinating field. It's a fantastic software, hardware, physics, and we should definitely choose.
What do you think of these new iron flow batteries that promise 100-hour storage and this new sodium batteries that promise to be 10 times cheaper than lithium?
Ali, look, I'm not very close. So it has their promise. What matters in the end is the levelized cost of storage. At what cost is being done. Clearly, iron is abundant, and we can have, of course, cost matters, right? And right, so these products or these need to certain scale for them to be economically viable, right? So, and which technology, which is the big billion dollar question that everybody's asking. So, not a lot of these will see light of the day in future. Sodium has a lot of promise, clearly, sodium ion. And I think what I say to consumers and to my customers is a huge impact to your economics, because it's very much comparable to where LFP batteries are now. Sodium is, of course, 10 times more abundant than lithium. So it solves the fundamental supply chain problem. It results in decoupling of battery prices from lithium, which has been a huge problem. And it's a demand-supply thing. And, of course, lithium needs to be mined and stay forever. You come on stream. So also is out there, more diversified this will be. And I think over time, this will result in more stable prices and better costing of batteries. Reliable, that's what the physics suggests. They tend to be a bit safer. Downside, they're less energy dense. Right, so there are pros and cons. That's the jury's still out on that, but definitely a good addition to the mix. And I think we need more diversity. We can't be dependent on one material that decides this will be the case. And I think we need more and more variety and diversity in our supply chain.
When do these peak contracts that have overburdened Pakistan's consumers, when do they expire? How long do they last?
Lots of contracts have expired. The older ones, which a lot of them expired, and the rest, there's about 5 gigawatts of them that will expire by the way. But then new contracts are coming on stream, and some of them are idle. And the thing about idle energy, while the variable trade-off, you can have a 2-3 rupee unit. But then fundamentally, the first 10 years, you're paying off the debt. So the capacity charge from those idle plants is very high. So it's, in the short term, it probably will make the power more expensive. But if you remember the heydays of a country like Pakistan, when we had large idle power, we had the turbine and large amounts of power was coming from these very cheap sources. We had good storage of water, so we didn't have a huge water problem. And we are a country, one of the countries most affected by climate change, and we face water growing costs. Over longer term, this makes better economics. I don't see costs going down. The cost might go up. New contracts, the charge will increase. The other thing is, of course, the variables inside our energy mix, they also where the prices will go. So what are those variables? Capacity charge. I said capacity charge will increase, and then going down. Cost of fuel, as we more different impact, but we still use a lot of LNG in the mix, imported coal. Third is interest rates. Anybody's guess where they're going? Probably going up in the short term, medium term. And then finally, dollar, USD. Because a lot of equipment is imported, the debt, more than 50% of the debt is, dollar debt. So this is into our power system. And anybody's guess where those variables are going, I think most of them tend to go up rather than go down. So again, going back to the utility debt spiral, if these factors play out and the power becomes more expensive, more defection happens, more distributed indigenous microgrids will be commissioned.
Where are most curtailed in Pakistan? Where are most of those located?
They are primarily south.
Where is the fiber optic grid located? Are there any power plants that are next to the fiber optic grid in Pakistan?
Honestly, I'm not an expert in that, Ali. But what you will see is the fiber optic network tends to follow the mainstream pathways for gas lines and for electricity lines, and they pass through, go through the cable and goes right through the heart of Karachi and all the way to Punjab, and then.
So, are there any plants on the past?
I think that being study, and I wonder why you pointing that out.
The reason I'm asking that is because I don't know if you've heard of Kimi K3.
Yes.
So it's the latest model, AI model from China, which is American friendly. So the China deploying a lot of these models, these throughout the rest of the world, right? Because they're all open source. So they're going to need a lot of data centers. And if you have, and right now the crunch around the world is energy. That's what's holding back AI and data centers. So if you have energy, idle energy, if you build a data center next to it, if there's a fiber optic grid to connect to the, for the output.
What cost of energy? What is the cost of energy? If you were to run those plants today, they're not very efficient. And if they're using heavy fuel oil or any imported fuel, then they will tend to produce
But data can multiply that energy into hundreds of thousands of times profit. So they can pay it if they have energy.
I think very interesting. I think that could be a way of solving for idle assets in the country, and not really looking at and how power hungry they are.
Everybody is power hungry.
Absolutely. I think, look, one of the things that we have been proposing to the government, and we've seen that wherever the data centers flocking to that place, like Ethiopia is one place, and Addis Ababa, energy is about only 3 cents. They can offer 3 cents power.
As well as we have geothermal there, which is super cheap geothermal.
So you've had some power in your data center operations, right? So they will go where power is cheap and power is available. And I think this huge queue that's up in the gas generator bodes well for wherever you have power available. So definitely, I think the government has to think about the new sectors where the cost of energy.
The entire and infrastructure for turbines. There's a huge backlog for transformers. There's a huge backlog for all the components you need. And the only thing stopping AI is energy. That is the bottleneck. And if you have energy just sitting around doing nothing, somebody can figure out that and make make use of it.
Into data centers. Some of the developers have launched. They're now thinking about large data centers. Watch that this going forward. All those will be traded and sold to the hyperscalers.
Buy them.
I've been saying to my customers, if you don't want to use them, if you want to move towards grid and renewable energy, then they will invest. The queue on those is about 5 years, 6 years on average, right?
And you got turbines around. You can just put data into it and use those. Well, Mujtaba, thank you for this inspiring and detailed talk, for tracing the blueprint of the autonomous infrastructure with us throughout the world. So again, at some point, follow up on the amazing things you're doing.
Ali, thank you for having me. It's a real pleasure talking to you. Look forward to another conversation at some point.
Yeah, and if you come, babe, let me know. We'd love to meet you in person.
Absolutely. We'll take you up on the offer of running next to the museum in DC. So
sure. All right. Thank you.
Thank you.